Ever wondered why a spoon gets hot when you leave it in a pot of boiling soup? This is due to a phenomenon known as thermal conductivity, and it's all about how efficiently different materials transfer heat. Let's dive into the world of metals, where this fascinating process takes place. Picture a rod, a special one, made up of 5 different metals: copper, aluminium, iron, lead, and brass. Each of these metals has unique properties that affect how they conduct heat. Imagine setting up an experiment to explore this phenomenon. Place the rod on a heat source and attach small pieces of wax to each metal section. As heat travels along the rod, it melts the wax. The metal that melts the wax first has the highest thermal conductivity, while the one that melts it last has the lowest. Copper is up first. Known for its excellent conductivity, it's no surprise when the wax melts almost immediately. Copper atoms vibrate faster when heated, passing the energy along quickly. This makes copper an excellent choice for anything that requires rapid heat transfer, like cooking utensils and heat sinks in electronics. Next, the aluminium section. It's not as quick as copper, but faster than the rest of the metals. Its lightweight nature and decent conductivity make it perfect for applications like heat exchangers in air conditioners. Moving on to iron. It's slower than copper and aluminium, but it still conducts heat relatively well. This is why cast iron pans are a favorite among chefs. They might take a while to heat up, but once they do, they hold on to that heat incredibly well. Turning to lead, a notoriously poor conductor of heat. The wax takes a noticeably longer time to melt. This property makes lead useful for insulation purposes, such as in the construction of nuclear reactors, where it's used to contain radiation. Finally, the brass section. Brass, an alloy of copper and zinc, shows a middle-of-the-road performance. Its conductivity isn't as high as copper or aluminium, but it's not as poor as lead. This makes brass a popular choice for musical instruments, where it conducts sound vibrations effectively. So, what's the takeaway? Each metal conducts heat at a different rate due to its unique atomic structure and bonding. This property, known as thermal conductivity, is crucial in a wide range of applications, from cooking to electronics and even music. So the next time you stir a pot of soup with a metal spoon or listen to a brass band play, remember, it's all about conductivity. The world of metals is truly fascinating, and it's all thanks to the incredible science that takes place on an atomic level.